Hi everyone. By the end of this video, you should be able to write quadratic functions from a graph in 3 different forms. We're going to talk about vertex, factored, and standard form. To start with vertex form is a form that shows you where the vertex of the parabola is. And the vertex of a parabola is the point at which the parabola changes from increasing to decreasing or vice versa. In other words, you can think about it as like the highest point of the parabola or the lowest point of a parabola, depending on what it looks like. Okay, so to figure out vertex form, or the actual function for it, we need to know what the vertex of any parabola is. In this case, the vertex is at -2, and we go up 5, 6, 7, 8. Okay, so that might be helpful information to know for vertex form. So to actually know what the equation looks like, I want to talk about the parent function of a parabola quickly. So parabola in its parent function form is going to be have a vertex at 0, 0, and then the graph is going to look something like this. And the equation for that is y equals x squared. Now, what this parabola has done is it has shifted to the left 2 units and up 8 units. Okay, so from our conversation about transformations, we can apply those transformations to this function here. So the red parabola is y equals x squared, but our transformed parabola with vertex at -2, 8 will start with a transformation, a horizontal translation. So it's going to move to the left 2 units on the x, which would actually be x plus 2, because x is always opposite of what you think, in the parentheses. And then it's going to move up 8 on the y, which is just what you think it is. So our transformed parabola will look like this. And this is what vertex form looks like. It may look familiar to you, or hopefully does, but essentially you are writing the equation in terms of the vertex. So now we would know our vertex is -2, 8. Now the one thing that is not included here is this parabola and this parabola do not have the same steepness or the same width. So there actually can be some vertical stretches or shrinks on any of these parabolas. And that comes from the value you multiply the function by, which we'll call a. Okay, so in order to find our a value, you might have an idea of what it is because you can look at it and say, well, it looks like it got steeper, so it looks like I multiplied the y values by something. But to find it more concretely, what you can do is you can pick a point that's on the graph. Doesn't matter what point. So I can pick this point, so on and so forth. I might pick one that has an x value of 0 because it'll be easy. And then you can plug it into the function to solve for a. So this is my -4, 0 point. I can plug in -4 for x and 0 for y and solve for what my a is. So let's do that. I get 0 equals a times -4 plus 2 squared plus 8. And if you solve this for a, it'll give you the thickness or the width, I don't know, the steepness of the parabola. So go ahead and do that, solve for a, and I'll come back with the answer. Okay, if you solve for a correctly, you should get a is -2, which makes sense because what that negative does is it takes all of our y values and flips their sign, which would bring them upside down, which would essentially reflect the parabola over the x-axis. So our a value should be negative if it's an upside down parabola. And then -2, it means you multiply the y values by 2, which will mean this parabola got taller, which would stretch it out. So the most common mistake is forgetting to solve for this a value, but remember the parabolas aren't necessarily the same stretch as our parent function. So you always want to solve for that a. Okay, so highlighted in yellow here is our final equation in vertex form. And again, vertex form is useful because you can just look at it and see what the vertex is. Okay, factored form. Think about factoring. Factored form looks like a factored parabola. Now, as you learned when you figured out the purpose of factoring, factoring can help us find our x values, which can help us find our x-intercepts, which on this graph would be right here and right here. So when you think of factored form, I want you to think of factoring, which will help you think of x-intercepts. Okay, you'll need the x-intercepts for factored form. So this x-intercept is 0, 0, and this x-intercept again is -4, 0. Okay, so factored form is what the parabola is going to look like after you factor it. So really you have 2 x-intercepts. You have one is x is -4, and you have also x is 0. Okay, if I want this to look like factored form, I have to go backwards. So let me just go off on a tangent here, and you do not have to write this down, just watch. If I had something along the lines of y equals x plus, I'm making this up, x plus 2, and x minus 1. Okay, to solve for the factors or the zeros or the roots, whatever you want to call them, I would use the zero product property and say when my y is 0, what are my x's? And x would either have to be x minus 1 is 0, which would be x is 1. Because if you plug in 1 here, you'll get 1 minus 1, which is 0. 0 times this is going to be 0. Okay, or it can be x plus 2 equals 0. So you get x equals negative 2. Okay, so what we have now is the end result, and we need to go backwards and figure out what it would look like factored. So we need to get that set equal to 0 instead of saying x equals negative 4. So what we can do is we can take that negative 4 and move it over, and then you're going to go backwards. So I'm going to add 4, and you'll get x plus 4 equals 0. Or I can, I don't know, add 0. I don't know. There's no point. So really it's x plus 0 equals 0. Anywho, so that means our two factors are x plus 4 and x plus 0, which x plus 0 is just x. I'm going to write it down anyways, though, because it will be important. So what our factored form is it looks like what we would have before we actually solve for our x-intercepts or our x values. So it'd be y equals x plus 4 times x plus 0, or you can just say x plus 4 times x. Okay, so if you went back and used the zero product property now, you'd say x plus 4 equals 0, and you'd get negative 4. So I've gone backwards. Now, this is what factored form looks like, except again, this parabola, as we learned from vertex form, has been stretched out. So there is an a value here. And the nice thing about the a value is that the a value remains constant through all the forms. Okay, so if I want to know the stretch or the shrink on this, I could solve for my a value by plugging in a point. So I could plug in like this, this, but I would get a is negative 2 because it's going to be the same in every form. So my final equation would be y equals negative 2 x minus 4 times x, or really how you could write that is negative 2x times x plus 4. Again, you could say x plus or minus 0, but why not just leave it as x? And that would be your final answer. Now, if you want to test my theory that negative 2 is still the a value for this, go ahead and actually plug in, I don't know, plug in this negative 2, 8 into this form here, and you'll get that the a value is negative 2. So if you want to, test that on your own. Okay, our last form is standard form. And standard form is just the form that it looks like before you factor. So standard form might look like y equals 2x squared plus 3x plus 1. Okay, that would be standard form. And in order to find standard form, all you have to do is multiply out either vertex form or factored form. It's up to you. All of these forms are equivalent ways of writing the equation for the parabola. They're just written in different forms, where factored form is helpful to finding the x-intercepts, vertex form is helpful to finding the vertex. So since you already have it in two forms, all we have to do is multiply out to find standard form. So let's say I wanted to multiply this out. This one looks the easiest to me to multiply out. I would write down my factored form, and then I would distribute the negative 2x, and then I would have it in standard form. So negative 2x times x gives me negative 2x squared. Computer. Negative 2x times 4 will give me negative 8x. Okay, there is no constant in this case, which is fine. This would be my equation in standard form. So I converted from factored form to standard form. If you multiply out vertex form, you should get the exact same thing. So if you would like to test that theory just for some practice, you would have to expand this binomial, x plus 2 times x plus 2, then multiply by negative 2, then add 8, and again, you should get the same exact standard form. Okay, so test that theory if you wish. Those are the three different forms: vertex form, factored form, and standard form. I'm going to leave this problem here for you to try on your own. So can you write the equation for this parabola in all three forms? Okay, I will pause the video and do this so you can check your answer, but I will not go through it. So go ahead and use this as a self-assessment, see what you get. Okay, again, make sure you try these on your own, but if you've done it correctly, these are the three forms you should get. Don't forget about your a value, because this parabola is clearly wider than a standard parabola. And the reason is because you've divided all the y values by 4, which would smush the parabola together. Okay, so if you just got x minus 3 squared minus 1, don't forget to put an A here, plug in another point, and it'll tell you how the parabola has been stretched vertically. Okay, and the A value should stay the same for all of them because they've all been stretched the same or shrunk. And this is factored form, and if you multiply out factored form, this is standard form. 6/4 can be written as 3/2. I just left it like that because I wanted you to know that I distributed the 1/4 out to all the pieces. So that is how you would write a quadratic function from a graph. If you have any questions, please bring them to class. Have a great rest of your day.